This is Project 4 intro podcast for the LED show message or local weather. Purpose of this IoT project is just show Rockford weather, temperature and weather, or a message. The message is sent from the Blink app, and there's a button on the Blink app to control whether temperature and weather shows or custom text that you send. So here's a video. So first thing is the parts: photon, LED link, and it does come with the initial set of wires to plug into the device and also to the board. The problem with this one is the resistor is also needed in this project. So I give you enough wires outside of this also to be used. But you'll see that in a second. Take that back. The project uses the wire that comes with the LED that is provided in the package. And the difference for this week is instead of plugging the wires from the sensor to the breadboard where the photon's plugged into, you're going from the sensor directly to the photon. So you have in this, as you can see here, the VIN, the ground, D1, D2, and D3, corresponding with the same pins on the sensor. Another Blink app like we did in Project 3. You are creating a new project link here this week as well. To get the weather hook to work, we need to sign up for a weather service, and I like the openweatherapp.org. It's a free service for developers that gives you an API that you can use to determine the weather as it is right now. And one of the things I do not go over in that project for week 4 is this weather app hook. And I will do that here in a second to show you kind of how it works outside of the app, what all the readings are for the API. We'll go through the steps of setting up the weather API through the weather hook, follow the examples there. The particle app itself does utilize a couple libraries as well as Project 3 did. So you have a Blink library, the LED matrix Max 219 to Max 221. That's the range of LED matrices that's used. So you need both those libraries. You'll need the authentication code for Blink as you did for Project 3. It initializes the LED for the LED matrix. It's an 8-bit width for the matrix that we use. The web count is 9001. It's going to fire every 15 seconds or 15 minutes, for the weather. The default message to the LED when you hit the text button on the Blink app is hello world, hello RVC class. The initial mode is 0. There's going to be 3 modes actually, 0, 1, and 2. 0 and 1 is for the temp or the message, temp or text button tapped on the Blink app. 2 is for the turn off, which puts it in sleep mode until you turn it back on. So you'll see that in a second. Sleep time, 60 seconds. The length of the text initialization that you type in the Blink app, the default position for the text, making sure it's outside, then scrolls in from the left using this code here. Again, the text is a bitmap width, and the font is 5 and 1 space in between each letter. And if you want, you can play, once you get it running properly, you can play with these numbers to see and tweak them actually to see what it looks like on the LED. You can play with those as well. But I wouldn't do that till after you get it running properly. The next one is a text draw or draw text string. When a message typed in a Blink app, it comes to this function and it determines the LED layout for those letters that you typed in to where they show up properly on the LED. And this code is actually from the Adafruit code builder. And this one I would not change because it's going to mess up the font or the text actually in the draw. The setup is to initialize Blink, then initializing the LED matrix to utilize pins D1, 2, and 3. And the description on the comments in here, I try to be as much description as I could for each one of these lines of code. I put in here on this line here, my pins vary from the default. They add a matrix in the order in which they have been connected. The first matrix in a row, this first matrix in a column, and then vertical orientation, which is minus 50. I'm sorry, minus 90 degrees. No mirroring. Last 3 arguments on that one are no mirroring. And then the 4 matrix elements. So here we have 3, 2, 1, and 0, which is the matrix blocks. There's 4 blocks on the matrix, and each one of these drive those blocks. The particle publish is the initial hook for particle that you'll create. The connected, Blink connected, constantly syncs a Blink of any changes. The Blink write says here in the Blink app, I use a terminal widget on the virtual pin 1 to send the signal to the Blink or from the Blink. Send a text message to the display. So Blink write is going to take that display and it's going to push that information properly. Blink write V1 and then Blink write V2 is a button to toggle on and off the temperature. Virtual 1 is for the text message. Virtual 2 is for the temperature. Virtual 3 is for the shutdown button or shut off button. The void get data, weather data, just does that, gets the weather data and publishes it to the weather event. And you can see that on a particle event. The loop continually runs the Blink. It looks, if the web count is greater than 90,000, meaning 15 minutes, it'll do a publish of the temp. Publish of the temp is what's going to be used to update the temperature within the, to get the temperature actually from the service that we're using, the API service. So we're not using it over, every minute or 30 seconds. It's being used wisely. So let's get to the modes. If mode 0, it's going to be the weather button that they tapped on the link on the Blink app, and it's going to push to the Blink or to the LED the weather. Mode 1 is text message. It's going to push to, once they typed it in and sent it in the Blink app, that message that was typed in and sent is going to be sent because it's mode 1. Mode 2 is going to set the entire system to sleep for 60 seconds. And that's important. Because what's going to happen is once 60 seconds comes up and this runs again, you can, within the app, toggle the off button to on. And after that 60 seconds, it's going to change it from whatever mode to whatever you tapped on, which is going to be either text or weather. Mode 2 will be taken out of the loop because only one of these modes can be fired at a time. So if you tap on the button for text, it's going to be the 1 mode. If you tap on the weather button, it's going to be the 0 mode. If you tap on the off button, it's going to be the 2 mode. The web count in a loop is just incrementing by 1. So if the LED is not equal to null, it's going to draw that text onto the draw text function. Then it's going to animate it. The text animation is ending when the whole text is outside the bitmap. So after the last letter is outside the bitmap to the right of the bitmap, then it's going to begin animating again, but only after that's exceeded the edge of the LED. So if text X is less than text length, font plus space, then what this is going to do is manipulate that animation. Again, once you run it correctly, everything's working, you can manipulate this as well. The trick I always use is I will comment out a section I want to test on, copy it, put the comment line in there, paste below it, play with it, and if I don't like something or I screwed up, I can get rid of the one I was testing and uncomment the original line of code. That way I don't lose what I had before. The LED flushed out here. If the text is less than the length of the text, meaning it's off the right side of the LED, it's going to clear out the LED, delay for 800 milliseconds. Then it's going to fill, it says LED fill screen false if the LED is not equal to null, but the text is off the screen. Else, if LED is not equal to null again, because you'll notice here the if LED is not equal to null, you got this function here, this if statement here. Then it's going, and that's just one if statement, by the way. Then you have another outside of that, which is actually, there's 2 if statements going on here. The first if statement, here's the else if. The second if statement is a standalone if statement, this one right here. The first if statement is if LED is not equal to null, it's going to fire everything to here. If it is equal to null, if LED is not equal to null, then it's going to shut down true and delete the LED and make it null altogether. Okay. So that concludes Project 4, LED Show Message or Local Weather Introduction. Enjoy.